What is the incommensuration theorem? ICT.
I think that in the interests of uh, trying to keep things kind of organized, what I'm going to do is I'm going to basically talk about the ICT, or the incommensuration theorem. I use the word incommensuration theorem as the name of the thing, and ICT is the abbreviation. Um, and to basically describe kind of what we're going to do, or what the overall kind of structure or shape of the proof is. Go through the proof kind of once, not necessarily super tight, but enough so that you can actually sense what is happening, and then try to come back and respond to the questions you have. So in effect, what we'll end up with is effectively like three passes through it: one in a sort of outline form, one in kind of a essentialized form, and the last one in a sort of here's how to work out the details with respect to some of these questions that are being asked. So in that sense, just be aware that we're going to be going through this particular thing in three separate ways, just so that you kind of know the pattern of how I'm intending to speak about it, at least. And there is of course a risk I'll get distracted and go somewhere else, but I'm going to try to hold to that pattern. We good with that?
Sounds great to me.
Okay. So the overall flow is to first look at what the notion of measurement or interaction, or what we might call in the metaphysics this thing called the root tautology. So in other words, what's motivating us to think about comparison, and why is that important? Then the second part of the proof is essentially um, using or identifying the intrinsics of comparison, right? Recognizing them as intrinsics. The next stage is, with those intrinsics, defining the primary terms, in this case, symmetry, asymmetry, continuity, and discontinuity, and showing that those definitions are in fact complete and correct for all the usages of those terms, and why those terms are particularly important. So, in effect, there's a methodology here of essentially looking at definitions, having those definitions be shown to correspond to the way people are actually using it, but also show why those particular concepts are important in the field of study of both math and physics and other things like that, why they're important in philosophy, basically. Then we make some observations about the ways in which, under an axiom 3 sort of sense, that these um, concepts themselves can't just occur in any sort of context, that they have to, in effect, have certain kinds of mutuality based upon the characteristics of the definition. That's the core of the proof itself. So the ICT is what happens when we emerge, when we notice what emerges out of that consideration. So in other words, the result is statements about how symmetry and continuity, asymmetry and discontinuity combine. And what implications that has is therefore contingent upon the way in which those terms were defined. Like, for instance, in the first part, we showed that what measurement was about and why comparison was important. In the second part of it, we showed why the definitions of symmetry and continuity needed to be thought of this way and why those are important. And then we see, after we figured out the sort of proof of the incommensuration theorem based upon the observed intrinsics of these terms, that we can then make predictions or make observations about the fundamental structure of key domain relationships. And that closes out the overall proof. So in other words, it's what's motivating us, what are we doing with these definitions, and what does that allow us to do? And then as a result of what that allows us to do, what we can then do from there. That's the rough shape of it. Um, I think the overall stages of the proof will become clearer as I now do the second part, which is essentially to say, okay, we've just given an outline of sort of what the syllabus of the proof is. And so now I'm going to actually start talking about the proof itself. I'm going to begin the second pass. Are we good on the correspondence between where we are in the conversation and the plan I had set up earlier? Yeah. Okay. Tell them what you're going to say, then say it, then say what you just said. It's a really good speech process. I've definitely attempted to embody that as far as I can. Um, so the first part of why we would basically care about the incommensuration theorem is essentially the observation that for the main things that we would think about philosophically, or for the main things we would think about in terms of understanding physics or the foundations of domains, we notice that insofar as things like the scientific method depend upon perception, i.e., I observe a phenomena, I make a hypothesis, and I test the hypothesis, right? All of those are firsthand interactions, right? I'm either noticing something in the first person, I'm imagining a particular model in the first person, and then I'm testing that model in the first person. So, in this sense, the very action of doing the scientific method, which, by the way, is an example of or a particular um, manifestation of what we would consider to be theory of epistemology. Epistemology is the question in metaphysics: how do we know? Right. So, if we treat the scientific method as being a methodology that is a clarification of the how part of how do we know, then we're basically looking at perception or firsthand interaction as essentially being particularly important. I.e., can you think of any notion of the scientific method or any notion of epistemic process of knowing that is not in some way based upon perception or based upon measurement? And if you ask that question, it's pretty much the case that actually everything is understood in terms of perception or in terms of measurements, as far as conceptual understanding is concerned, as far as this phenomena of knowing is concerned. So if we basically are wanting to understand something essential about the nature of epistemic process, then we would want to understand what is essential about the nature of perception, or the nature of measurement, or the nature of comparison. And in fact, we can make the observation that every measurement is a perception. I perceive that number is the result of what's on this dial as a result of some interaction that's happening, right? Or I can think about every perception as having some sort of objectivity associated with it, some sort of subjective and objective characteristic. I can notice that every measurement is a kind of comparison, and every comparison is a kind of measurement, and every measurement is a kind of perception, and every comparison's a kind of perception, and perception's a kind of comparison, and so on. I can basically show that in time, everything that is relevant to epistemic process is going to have a concept of this type, some sort of immanent concept type. And so, we're basically noticing here that without the notion of interaction, no theory of physics even begins to make sense, and no idea of science even begins to make sense. Like we are effectively compelled in epistemic process, whatever the nature of that process is. This is now extending beyond just science, but the idea is that any version of the epistemic process is to some extent going to be based upon the notion of knowing, or the notion of perception, or some analog of measurement or comparison. That these concepts are all in effect measurement, comparison, perception, knowing. They're all of the same type. They all have essentially equivalent functions. And so this idea of general equivalence of the immanent modal type, if I'm sort of skipping ahead and presuming that there's some meaning behind the notion of immanent modal type, I'm just going to make the observation that all concepts of the immanent modal type are at the very foundation of what we mean by the notion of the epistemic process itself. The actuality of the epistemic process is reified in terms of this fundamental type. And so insofar as all of these concepts, perception, measurement, and comparison, are in a sense strictly equivalent to one another. And when I say strictly equivalent, I'm saying in the sense of the epistemic process, i.e. the process of knowing. Then anything that we say that is intrinsic to the nature of any one of them is going to be intrinsic to all of the others. So if I happen to know something about comparison, then I also know something essential about the nature of perception and the nature of interaction and the nature of measurement. And this is getting actually to one of the questions that Ben was asking, which is, can we think of the notion of perception in terms of 6 intrinsics? And yes, it turns out we can. Can we think of the notion of measurement in terms of 6 intrinsics? And yes, it turns out that we can. Can we think of the notion of comparison in terms of 6 intrinsics? And yes, in this case, it turns out that we can. And for the purposes of this particular presentation, I'm just going to focus on comparison, because in that case, the intrinsics are the most obvious. So in other words, there's the least impedance mismatch between our current understanding and the understanding of the nature of the intrinsics of comparison. It's actually easiest for most people, so far as I can see, to accept the intrinsics of comparison as actually being intrinsics. But if you look at the intrinsics of measurement, or the basic measurement types, in this case, I would list them as, pattern in space or mass in space. And in this notion of pattern and mass are essentially the same concept, but that's a technicality. I'll leave that aside for now. Then we have forces in time and probability of each possibility. So those are essentially the basic measurement types. And if you look at those, you might be able to say, yeah, it's actually the case that we can think of other metrics, other measurements, as being built up out of these sort of atomic measurement components, right? That if I'm thinking about energy, I'm thinking about things like forces in time and states, which are probabilities and possibility, right? So I can have the state of the stone sitting on top of the hill as compared to the state of the stones sitting on the bottom of the hill, i.e. Two different states. And that gives me a notion of potential energy. Or I can think about it in the sense of the stones rolling down the hill, and it's going pretty fast by the time it gets towards the bottom. And now I'm thinking about forces in time, right? And that either way, the notion of energy is going to be thought of in terms of some combination of forces in time and probabilities and possibilities. And that actually covers quite a lot, right? If we're thinking about the notion of energy, we can understand it in these metric terms. But in this motion, at this particular moment, rather than looking at the intrinsics of perception, which you can look up in the book, it's in the white book. I don't happen to remember the section number at the moment, but you'll see that everything in the white book has this, 1, 2, or 3 dot, and then a section number, and then a dash, and then the particular aphorism number in it. So in effect, somewhere I can look up that number and tell you what are the intrinsics of perception. You'll probably find it in the index. In any case, rather than thinking about the measurement types or the perception intrinsics, I'm going to focus on the intrinsics of comparison, because the idea of the comparison intrinsics allows us to say things that are true for all of the other types of things that are in the immanent class. In this case, measurement, observation, not only comparison, but perception and knowing. So if I really want to understand the fundamental nature of the epistemic process, what is possible to know and what is fundamentally unknowable, then I'm going to want to understand something essential about the nature of perception itself, or in this case, the nature of comparison itself, because that's going to be the basis by which I can actually even answer questions like this. So what are the intrinsics of comparison? Well, there are sameness and difference. That's one group. There's content and context. That's another group. And subjective and objective. And that's another group. So in other words, for every sameness, there's a difference, because I can't really have any notion of sameness or any notion of difference without already having implied the other concept. The same sort of way, I don't really have a notion of content without a notion of context, or vice versa, context without content. And I don't really have a notion of subjective without objective, or objective without subjective. And we know this because of this thing called axiom 1, which says that the relationship between sameness and difference, content and context, and subjective and objective is the thing. Right? It's the relationship is the binding element, but it also kind of makes the set. Now, the relationship of content and context doesn't have a name in English by itself. It's the unnamed thing that is between content and context. It has its own ontological status, i.e., we can have a concept of it, we just don't have a name for it. And we can talk about the relationship between sameness and difference. There's clearly a relationship there. The relationship is not a sameness, nor is it a difference, but it is definitely a relationship between sameness and difference. Again, its own ontological class. And it doesn't have a name either. And then we can talk about the relationship between subjective and objective. And in this particular case, we can say, well, there is a name for that relationship. We can talk about it as the plane of perception, like we did last week. We can talk about it, the notion of interaction. We can talk about the notion of comparison, so on and so forth. But it is actually the thing we're actually trying to work with itself. We can say that comparison is that which happens between the subjective and the object. Or interaction is the thing that happens between the subject and object. Again, all of the stuff between subjective and objective is of the immanent class. And this is, again, something that we've learned from the type isomorphism that shows up with the modalities themselves. So in effect, the subjective is going to be of the transcendent class, the object is going to be of the omniscient class, and the relationship between them is going to be the immanent class. We're basically saying that the notion of comparison is of the immanent class, as is the notion of perception and expression and measurement and choice, and anything that is real is going to live in the relationship between. The notion of real has to do with the relationship between the subjective and the object. So in this sense, what we're basically pointing out is that even the notions of choice, change, and causation themselves live in the real, live in the relationship between the subjective and the objective. You may remember from last week or the week before, when we were talking about it, I said the notion of the real is immanent in a way that the notion of the universe is omniscient. And just to complete the picture, the notion of objectivity would in effect be transcendent. But let's leave that aside because that's, again, technical language. We don't need to go into that right now. But it's important to mention as an aside, because if we're actually clarifying something about the immanence in terms of the notion of comparison, we're actually clarifying something essential about the notions of choice, change, and causation. Right? In effect, I'm saying that insofar as comparison and real live in the relationship between the subjective and the interaction, or the subjective and the objective in the sense of the interaction, then in effect I'm both explaining why I'm holding the notion of comparison important and what sort of scope of implication this has. Because, for example, if I'm talking about the great theories of physics, in this case, Newtonian mechanics, general relativity, and quantum mechanics, it is the case, particularly for general relativity and quantum mechanics, that they can only be understood in terms of measurement process. Right? The idea of the shape of the space-time continuum is in effect defined by the connectedness of, the topology of the space-time manifold is effectively defined by a kind of connectedness, i.e., the places where causal influence can flow. I'm alluding to this. Not all of this language will make sense to all of you, but there's this thing called the Minkowski diagram that basically talks about, there's a diagram and it looks like a cross, just a diagonal X, and the idea is that the only things that can affect the present live within the past time light cone, i.e., if it's farther away than a signal could get here, traveling at the speed of light or less, then it can't affect the present moment. Again, this is part of how general relativity sort of thinks about things. And if I have some signal that I want to send out to something else, the only things I can affect are the things that are within reach in the future time light cone, i.e., things that are available to actually be influenced by a signal that can propagate through space at either the speed of light or less. And so, in effect, the shape of the connectedness everything that can signal or affect everything else in this sort of four-dimensional continuum is the notion of what sort of causal effects, like every signal essentially is creating the possibility of affecting something. The signals, the emitter of the signal is the cause, the signal's the propagation of the cause, and then whatever receives that signal that's affected by it is the effect. And in the same sort of way that we're talking about this notion of signal, this notion of causation, as a notion of locality built into the very model of general relativity, we also see the same thing happening in the fundamental concepts of what is even meant by quantum mechanics. Right? Quantum mechanics is basically describing the evolution of potentiality over all of the possible states that occur between measurements, and the measurements themselves change the nature of the evolution of the probability and possibility. So in effect, the very notion of quantum mechanics is defined by the measurement process. And the measurement process is, in a sense, characterizing the evolution of the probability wave that follows after that. So this is essentially kind of what's held in the Schrodinger equation or the Dirac equation. But the overall concept to get out of this, and I know that some of these things aren't going to make sense to all of you, but the idea here is that insofar as we can characterize and cannot not characterize the fundamental theories of physics in terms of measurement process, in terms of causal process, in terms of things like observation, signaling, right? These are the sort of root assumptions out of which the very meaning of these theories is constructed. You cannot conceive of, there's no way to hold any meaningfulness of any theory of physics that isn't based upon this substrate. And this isn't debated. There's nothing questionable about this. This is just known and more or less taken for granted. So in effect, if we're saying, yeah, it's very uncontroversial to notice that all theories of physics, all theories of science are going to be based upon this measurement process or this assumption of causation, of signaling, and so on and so forth, and all of these concepts are effectively equivalent to measurement and comparison, then anything we can say about comparison is therefore going to have a direct bearing on the very substrate of what is knowable in these bodies of physics, point blank, period, right? Because it lies at the very root of the epistemic process itself. And in this particular rendering of the ICT theorem, I'm basically, most of the time I wouldn't go through these particular things. Mostly I would be talking to people that were already well versed in these kinds of things. And so, I would effectively just skip all this part, start talking about comparison, and then, lead them down the garden path a little bit, right? Because they'd say, oh, well, comparison's a thing. Yeah, I kind of know it's important, but they wouldn't have made the connections as directly as I just did. They would kind of take it for granted. And then we would go forward and we would essentially arrive at the incommensuration theorem result. And at that point, there would be this surprise. And it would be like, oh, yeah, oh, wait, no, how does it, wait? And so in effect, at that particular point, it's the classic example of leading them down the garden path to the point that by the time you get there, you realize that the gate's shut behind you and it's a one-way door and you can't unlearn what you just knew. So in this particular case, I'm giving you the advantage of forewarning you that this step of choosing to look at the intrinsics of comparison is a very non-arbitrary step because of these connections to the very ground of epistemic process, to the very ground of everything that has ever been learned in Western physics, like literally the totality of it. So anything that we do from this point that can actually say something concrete and unambiguous about the nature of comparison is therefore very, very powerful, very, very influential in the sense of what the implications are going to be for everything else that is all the way down the road from this. For the people that essentially hold that they can understand reality in a fairly fixed way, that this cannot not reorder their understanding of the universe. It's definitely a walking down the garden path in the classic sense. There's a whole literature associated with that. It's considered to be a tour of force. In this case, it definitely is. Not in the sense of dominance, but in the sense of, holy shit, we didn't know that was possible, kind of like surprise. But in any case, So that's what's motivating the choice of why we would pick this particular term. So it also kind of clarifies the structure of why we would hold the notion of subjective and objective essentially as constants and look at the interrelationships between sameness, difference, content, and context. So in the sense that we've basically described that the notion of comparison is in the immanence, it's in the relationship, then in effect, there's a kind of overlay between the instance of comparison between the subjective and the objective, and the fact that the subjective and objective is part of that betweenness. So in effect, I'm really concerned with the ways in which sameness, difference, content, and context work. Now, by the way, at this particular point, it's probably a good idea, if I was being especially thorough, to, in addition to showing that you can't think about measurement without thinking about comparison or any of those other root tautology sort of things. Like you notice there's a section in the book called the root tautology, and that's what I just covered basically. But the next piece would be to basically say, well, given that comparison is both understandable in terms of its intrinsics and cannot not be defined in terms of these intrinsics, like in the same sort of way I asked a week ago or something like that, is there any way of understanding the universe that is outside of creation, existence, interaction? I could ask similarly, is there any way to understand the notion of comparison without at least implicitly introducing the notions of content and context, sameness, difference, and subjective object? And that would be an exercise. Like if I was doing a Zen class, I would basically say, here's your koan, come back next week, let me know what you come up with. And in this particular sense, because I'm rendering the proof, I'm just going to basically say, there really is no way to think about the notion of comparison without introducing all 6 of those concepts. And it turns out that they are both necessary and sufficient. In the strict sense of the word of philosophical notions of necessary and sufficiency, the 6 intrinsics associated with comparison are both necessary and sufficient. So I can fully define the concept of comparison in terms of these 6 intrinsics. And it's unambiguous that these are, and uncontroversial, that these intrinsics are built into the notion of comparison. So in the sense that the notion of comparison is subsumed by these 6 intrinsics, and insofar as subjective and objective are holdable as constants when talking about the immanent modality in the sense of looking at the structure of it, I can then say, okay, what can we do with these concepts of sameness, difference, content, and context? And this is the first move. That is, everything I've said up until this particular point is just flat out uncontroversial, that basically says why this is important and what sort of things will happen if we do anything from this point onwards. But from this point onwards is essentially where new things start happening. So the first thing that is genuinely new that I'm essentially adding is the idea that the concept of symmetry can be proscriptively defined as being where there is a sameness of content and a difference of context. Now, at this moment, it might be a good idea for me to describe why it's important that this is a proscriptive definition rather than a descriptive definition. If I go to a dictionary and I look up the word symmetry, I'll see a whole collection of examples of how the notion of symmetry is understood by regular people. And if I go and I talk to a mathematician, like if I were to spend some time talking to Richard as, what is the concept of symmetry? Or I were to go and talk to a physicist and I'd say, why is symmetry important to physics? Like, what is the essence of the concept of symmetry? Forbid, denounce, or condemn. That's not quite right. Yes, in that sense, but it's the notion of proscriptive is, again, I'm coming from a philosophical reading, which on one hand, proscribe, if I was thinking about it ethically, would be to forbid. But if I was thinking about it in the sense of a definitional sense, a proscriptive definition is essentially one that has a perfected sharp boundary. So in other words, I'm distinguishing between the things that it is and the things that it is not exactly. It's proscriptive in the sense that I'm defining it in advance. So it comes from the older roots, proscribe. Pro meaning before or in advance of, and scribe meaning to cut a hard line, like a scribe. If I'm working in metallurgy, for example, or I'm working with tools, a scribe is a very sharp instrument, and when it scores the metal, that makes an irrevocable mark and a very precise mark. If I take I draw a line on a flat polished metal sheet with a razor blade, that line is going to be like really delicate and thin, and it'll divide the plate into what's on one side of the line versus what's on the other side of the line. The line effectively could be taken as infinitely thin. So the idea of scribing in this sense is to take that notion of perfected boundary to the extreme of mathematically precise. Delineate, yes. So in this sense, if I'm writing a piece of software, for example, I might say, in this program, I'm going to set this variable equal to this value. So the letter A equals 10, semicolon, right? And in that sense, the variable is going to have the variable 10 in this case. And there's no ambiguity. It's 10.0000, whatever, right? And in that sense, it's not 11, it's not 10.0001, it's not 9.99992 or anything like that. It's precisely 10. Whereas if I was describing it, I'd say, well, I only know it to be approximately close to 10. Right? Like I'm measuring something with a thermometer and I can only see, well, let's see, given the quality of my eyesight and how much I need glasses or something, I'm only going to say the temperature is probably between this number and that number, but where it is exactly, I don't know exactly. But in a piece of software, if I'm setting it to a number, I'm writing that number down in a discrete way. So the difference between observation and saying, I notice that these things look vaguely symmetric, to an expression, I'm saying this is what symmetry is really to refer to the difference of, is it a perception and I'm describing what I see? Or is it an expression and I'm telling you how I'm setting it up? So a proscriptive definition is I'm alerting that in a kind of mathematical sense, I'm defining this term explicitly so that I can use it formulaically. And this is a key move, because if I'm taking descriptive things and I'm trying to manipulate them in a formal logic sort of way, if I don't know what I'm manipulating, I don't know whether those manipulations can actually be done. Right? So for instance, if I have a proof and the proof depends upon 1 + 1 = 2, well, that only really works. The equality only works if it's exactly 1, another exactly 1, equal to another exactly 2, right? If it happens that the first number is 1.0001, but I only know the first part of it because I don't have in my measurement enough to distinguish some of the fine numbers at a good distance to the right of the decimal point, then it'll look like 1 + 1 = 2, but it won't actually be the case, because it's really supposed to be, that notion of trueness associated with the equality is because of the perfection of the idea of the integer being exactly what it is. So in this sense, if I'm trying to basically assert something in the notion of proof, I have to say it's not mostly the case. It's not mostly true. I have to be able to say it is exactly true. And in order to do that, I have to be able to say that something is exactly the thing it is, which means I need to switch from a descriptive way of doing it to a proscriptive way of doing it. So this notion of saying, I'm going to define symmetry in this exact way is, on one hand, it's a hypothesis, because I'm basically saying, well, does this way of defining the thing actually correspond to the way the word symmetry is used in the real world? And I'm going to assert that it does. And I can show that with examples. Then I can go a little farther and I can say, are there any counterexamples? Is there any place in the world where the notion of symmetry doesn't fit this underlying pattern that I have described exactly? And if it turns out that there's no example where somebody was using the term in a clear way, there wasn't an example of this underlying pattern, then we can make the claim that the proscriptive definition corresponds to the descriptive definition. So in effect, we could say that the meaning that we've given to the term is actually correct, right? I'm not making it up. I'm basically making an observation. Here's how the term symmetry is used in the world. Here's how I'm describing it proscriptively, and they correspond to one another, right? There's no counterexamples. And so in that sense, we therefore have confidence that our way of defining the term symmetry is good for the use of proof, i.e. that the semantic meaning of the notion is therefore semantically corresponding to the reality of the term in theories like physics and mathematics in the deepest possible way. And this is relevant because we are actually talking about things in the notion of comparison, which again is at the very deepest level, is the very foundation upon which epistemic process is itself known. Any theory of physics is known. Any theory of mathematics is ultimately known. Without there being both a absolutely clear sense that the semantic relationships are deeply held, it cannot not be held, and that the logic of the proof is in a sense strict, right? We need to establish both of these things as being true because, again, it's a garden path argument. It's what is called a rigorous argument. Again, it's kind of a joke in math, but they'd say a proof will convince a reasonable man and a rigorous proof will convince an unreasonable man. At this particular point, I need to basically show that it is for sure the case that the incommensuration theorem is a rigorous proof. And I know I'm sounding pedantic as all hell, but there's a clear example of I'm basically trying to show with a level of clarity as to not only what are the explicit moves that were being made, but why we are needing to make those moves. And this is a lot more detail than I originally wanted to do, but I'm realizing that the strength of the proof is literally contingent upon this sort of setup. So in that particular case, it's important to actually get a record of this. It becomes relevant in any real understanding of what this is that's actually happening here. So in effect, if we're basically saying that the notion of symmetry does correspond to the way they're using it, so let's actually talk about that just as a sort of relatable example. So for a sort of metaphor, and this goes back to I think a question that Ben was referring to, and is one that's actually in the document. But sameness of content and difference of context, right? So what do we mean by sameness of content? Well, say for example, I have a tessellation, like I have a piece of graph paper, and it's got the sort of XY grid on it, right? Just and for the sake of argument, let's just imagine that I'm looking at one square, like I basically to bring it back into the first person sense. Okay, so imagine a plane that's got a graph paper sort of look on it, like one of those sort of virtual reality shows where they start with this grid that you're standing on, and there's objects around you, right? And they're all sitting at various positions of the grid. And if you were to take the grid and shift it to the left under your feet by one square, you wouldn't be able to tell that shift had happened, right? Because the grid would look the same. If I were to take the grid and, again, say you blinked, right? So you closed your eye for a second, and then somebody took the grid and turned it 90 degrees. And then you opened your eyes again, would you be able to tell that the thing had been rotated 90 degrees? No, of course not. It's a regular grid. If I was standing on the grid and I was to have, again, you blinked, and in that period of time, somebody flipped the grid over, turned it upside down. Would you be able to tell that it was upside down? Well, it's just lines in space, or it's just lines on paper and whatever. It looks the same. Now, if instead of my standing there and the grid moves, say, for example, I was to have my feet glued to the grid when it flipped over, or when it turned 90 degrees, or when it slid to the left by 1 unit. Now, in that sense, I would notice that the context had changed. Even though the grid still looks the same to me, I would notice that if I slid to the left, it would be as if all the objects in the universe had shifted to the right. Or if I rotated the grid 90 degrees, then all of a sudden stuff that was in front of me would all of a sudden be to my left. And the stuff that was my left would be behind me. The stuff behind me would be on my right, and the stuff on my right would be in front of me. I'd noticed that the universe, the context had changed, even though my own relationship to the grid had not changed. So again, notice that in each of these cases, we're seeing a sameness of content and a difference of context. And that, in effect, there's if we were doing this conversation on a holodeck, we could just demo this and you could experience it in first-person virtual reality. And of course, nowadays, VR cameras are good enough that we could do this as a visual experience. You could actually, I'm just asking you to imagine that. But yeah, we could set up a demo of this, and maybe I could get some friends that are doing VR to actually write up this scenario. And in fact, that might actually be a way to convey some of these ideas of the metaphysics. It would be I don't know, a VR reality tour of how to imagine some of these things. But again, the abstraction itself would be so much that it would be a pretty Spartan world. In any case, the notion here is that if I'm looking at symmetry in this sort of sense of sameness of content and difference of context, then we could kind of create this sort of understanding of the pattern. But what are other examples of symmetry? Well, again, thinking about physics as an example rather than just math in the sense of symmetric tilings, I can think about, say, for example, the notion of conservation of matter and energy, i.e., that the amount of matter that is here in the universe right now is going to be the same amount of matter and energy that is in the universe 10 minutes from now, right? There's content, matter and energy, and context, what it says on my clock. So in effect, the context has changed, what time it is, whereas the content, how much matter and energy, has stayed the same. So we would say that the notion of conservation of matter and energy is an example of a symmetry. And it turns out that almost everything that's interesting about physics is an example of symmetry. You talk about gauge symmetries, or the notion of lawfulness itself as being an example of symmetry, i.e., the idea is that we have the same physical laws applying everywhere in the universe, right? The laws would be content, and the rest of the places in the universe, like they apply here, they apply in Paris, they apply on the moon, and they apply on some planet floating around some star on the other end of the galaxy. And so in effect, the context change where we're looking at, where you happen to be testing them, that's different context for sure. Same laws applied 1,000 years ago and will presumably still apply 1,000 years from now. So again, different times, different context, but the same laws. Content's the same, context is different. So the very notion of physics, in a sense of telling us anything about the regularity of the universe, the idea of the universe has regular structures, is essentially an expression of symmetry. So therefore, we can start to observe that the notion of symmetry is at the very foundation of both math and physics. Cannot not be. Right? To say that something is true, like even in the notion of proof, I start with these sort of premises. So like in geometry, for example, you have the 5 postulates. And there's this notion of truthfulness applied to that collection of postulates. And the notion of these transformations, I can combine these things in a geometric process involving a straight edge and a compass. And from that, I can construct ideas about things that are also carrying this property of truthfulness. That if we assume the premises and we assume the transformations of these premises involving these two tools, compass and straight edge, or points and lines, basically, that we can know that the constructions also carry the same truthiness. So the idea of truth, in a sense, is held as the content, and the particular statements are treated as the context. So in that sense, the idea that the proof is identifying a kind of regularity in the structure of all possible things that can be known, mathematically or physically, then in a sense, the idea of the very notion of having a body of knowledge in math and physics or any other science is very much based upon this notion of symmetry. So anything that we are saying about the notion of symmetry is going to apply in the most profound way about everything that is knowable, including everything is knowable in a scientific and mathematical sense. And again, I'm belaboring this point because, again, as we walk down the garden path and we begin to make some observations, that talk about the relationship between symmetry and continuity and asymmetry and discontinuity, we're basically saying something that is profound about the nature of what it means to know anything at all, right? So when I'm basically claiming that the incommensuration theorem is delimiting the relationship between the known and the unknown and the unknowable, to actually be able to say that we can delineate something about the relationship between the knowable and the unknowable in a precise and exact way is actually to have done something extraordinary. In effect, I can know something about that which is otherwise unknowable. I can have a kind of meta perception that encompasses the totality of what it even means to have perception itself. We can now talk about the process of perception in some sort of way that is inclusive of itself. It's actually it's a realization of the metaphysics is describing itself. It's a second order phenomena of that, and in the most profound way, because we're literally talking about the very roots of epistemology and therefore of ontology and axiology itself. So this is an incredibly important result that we're developing here. So in the sense that the notion of symmetry is built into the very essence of what it means to have a body of knowledge, then the idea that we can now describe it proscriptively is kind of a big advance, right? Because it's connected to the very basis of the immanent relationship, i.e. the notion of comparison is defined in terms of comparison, which is also at the basis of epistemology. So now we're building up some momentum here. So it's like, okay, well, if I can define symmetry as being exactly the notion of a sameness of content and a difference of context, and we know that it corresponds to the very root of what it means to knowing in much the same way that comparison itself does, which makes sense, right? Because the definition of symmetry was based upon just the primaries of the concept of comparison. So of course they would have basically the same level of depth. So in this sense, when we say, okay, well, what else can we do? Well, I could talk about discontinuity, and I can talk about asymmetry, and I can talk about continuity. And they're all defined in similar ways. And so if you look at the actual essay part of it, and I won't go into details too much, but basically the idea here is that asymmetry, continuity, and discontinuity are all themselves definable using just the language of sameness, difference, content, and context, and nothing else. And in the same sort of way that we are able to show that there is a, in the analytic sort of validity sense that these definitions can be proscriptively defined, they're also in a absolutely tight, unambiguous, semantic relationship to these terms as they occur in common usage. So every instance of discontinuity or continuity or asymmetry also corresponds to the proscriptive definition as given in the essay, in the actual language of the incommensuration theorem. So in the actual essay, the incommensuration theorem, I spend some time defining these terms, and I would spend some more time basically showing that the semantic relationship actually holds. But in this particular case, I only really want to talk about the continuity one because it's not so much that the analytic piece is the important part. It's actually that the analytic piece is happening within the context of these absolutely unambiguous semantic relationships. These semantic correspondences are unavoidable and uncontroversial. And so in that sense, why would the notion of continuity be important? Well, first of all, it's built into these theories of knowing themselves, right? The very idea of a first person perspective is to imply that there's some connection between the subjective and the object. There's some connection that is created in the immanent process. And then in the same way that the proof, there's some connection between the premises and the conclusions. And that connection is through the methodology of the straight edge and the compass. Or in physics, it's through the methodology of measurement and signaling and causation as ideas, or through the notion of metrics as ideas, or even the notion of questions and answers as ideas. So in this sense, there is there's a very strong reason that we would be interested in symmetry, and a very strong reason why we'd be interested in continuity. Because in the sense that the notion of symmetry describes fully and comprehensively and cannot not be the basis of everything that is knowable about the object. It is also the case that the notion of continuity is at the essence of everything that is knowable about the subject. It is not possible to have knowledge of the objective that isn't symmetry-based. And similarly, it's not possible to have knowledge of the subjective that is not continuity-based. So these concepts of symmetry and continuity are at the very basis of the epistemic process, point blank period, in the most profound way conceivable. And this also is unambiguous. So therefore, we're really working with some things that are as deep as it gets, basically, right? The axioms and modalities are at the very core, right? And now we're using them to essentially show that there is this distinctness, inseparables, non-interchangeableness, and that, moreover, that these relationships of analytic sort of validity and soundness / semantic are deeply entrained in and deeply intrinsic to the very basis of knowing an epistemic process itself, and therefore also of any notion of the projection of the basis of being itself or the basis of value itself. So in effect, we're dealing with what is quite simply probably the deepest possible proof that's able to be done. I don't know that there's any deeper substrate with which we could even work. This might actually be the proof from which all other proofs even have any notion of being a proof. That's a very strong claim, but look at the ingredients we're working with, right? Is there anything that could be more profound than the ingredients we're actually talking about? Actually, no, right? This is as deep as it gets, right? We're talking about the very notion of consciousness. We're talking about the very notion of causation, or the very notion of change or of choice. Like this is written into the ground substrate of what it even means to know anything. In the sense of I think, therefore I am. We're also talking about the very basis of being. So these intellectual tools aren't just intellectual tools. They're talking about the nature of isness. So in that sense, if we're looking at this as being a rigorous proof, it's the primary concept of rigor. And again, this is important to state, because at this particular level, we actually need that level of clarity. We need to be super certain. So and the reasons for why we need to be super certain have to do with things like, why ethics is important and how to make good choices and so on and so forth, particularly in the area of existential risk. Any caliber of tools that was less than this would be insufficient. But that comes downstream of this point. So let's go back to where we're at. Okay, so we're about maybe halfway through, but it gets easier from here in a sense. So we have these four terms: symmetry, asymmetry, continuity, and discontinuity, which are proscriptively defined and therefore available for analysis, available for a kind of recombination, right? In the same sense that I can, talk about 1 + 1 = 2 because I have an exact notion of one, an exact notion of addition, an exact notion of equality, and the exact notion of two-ness, that in a sense I can have an exact notion of 1 + 1 = 2 as true, right? That the notion of equality as bearing truth and falsity in the sense is going to establish that if I have clarity around these other concepts, if they're exact in the sense that I'm talking about, then I can have confidence in the notion of the equality actually working. So in this specific sense, we can say, okay, given that we have exact notions of symmetry, continuity, asymmetry, and discontinuity, what can we do with this? Well, the obvious thing would be, can I apply these concepts to one another? Can I have symmetric discontinuity? Turns out you can. Can I have asymmetric continuity? Yeah, turns out you can. Can I have perfected symmetry and perfected continuity? Nope, turns out you can't. And this is where all of a sudden we get an unexpected answer. Because the big assumption of both physics and mathematics and literally just any other Western thinking and maybe even Eastern thinking, I'm not sure, I'd have to check that, but that literally every concept that every philosopher has been trying to develop all this time is tacitly assumed that you could have symmetry and continuity at the same time. And we've just noticed, and how did we notice this? Well, it actually turns out to be quite simple. For every sameness, there needs to be a difference. For every content, there needs to be a context. That's unambiguous. But if I look at the way the terms are defined, if I try to apply symmetry and continuity at the same time, I notice that I have a situation where I have if I look at the definition of all of these four terms, all of them have exactly one instance of content and exactly one instance of context in each of the definitions. So there's four definitions. Each one of them has a content and a context built into the definition, and they are all one-to-one. So no matter how I combine them, I'm always going to have content matched with context. But is that also true for sameness and difference? And it turns out it isn't the case. So for example, there's a notion of continuity as having a sameness of content where there's a sameness of context. Now that works by itself to define the notion of continuity. But if I were to try to combine continuity and symmetry, I would notice that, well, symmetry is bringing one notion of sameness and one notion of difference, and continuity is bringing two notions of sameness. So therefore, the combination is going to have three instances of sameness and only one instance of difference.
What is an example of continuity?
The easiest one that I've found is to, in mathematics, the notion of a continuous function is one that for an infinitesimal change on the x-axis, I don't end up with a abrupt change on the y-axis, i.e. that the slope doesn't go to infinity. That in effect, if I were to have an arbitrary difference in the y-axis, axis, for a arbitrarily small difference or no difference at all in the x-axis, axis again, then in effect, I have a difference of content and a sameness of context. And that is the essence of what is meant by a discontinuous function. And mathematics uses this term in exactly this way. So in effect, discontinuity would be where there is any sudden break or breach or separation that is otherwise, it's like an edge between things, where the thing that's on one side of the edge and the thing that's on the other side of the edge are completely different, and the edge is infinitely narrow. That would be a discontinuity of sorts. So I hope those examples help. We're good. Okay. So in this sense, think about it as a sort of chemistry. For every sameness, there must be a difference. But when I combine, or I attempt to combine, symmetry and continuity, I end up with 3 instances of sameness and only 1 instance of difference. And that just doesn't work, right? Under axiom 3, we basically are we're having two instances of sameness more than that are unbound to an instance of difference. And so in effect, we might say, well, okay, where else does that show up? Well, if I try to say something is symmetric and asymmetric at the same time, in the same way, I end up with that same sort of chemical imbalance. Okay, that makes sense. If I basically try to say something is itself and its opposite, right? That's clearly a doesn't make sense. And this sort of chemistry way of looking at it of counts of sameness and counts of differences account for that. If I apply sameness to itself, well, I haven't added any semantic value, and it turns out that these counts also account for that. If I basically try to, look at even asymmetry and discontinuity, I also end up with this doesn't add up phenomena. So we've now just learned something, that in the same way that symmetry and continuity can't be combined, that asymmetry and discontinuity can't be combined, that literally the only possibilities, like if I take and I set up, okay, I'm going to take the 4 of sameness, symmetry, continuity, asymmetry, discontinuity. I've got this set of 4, and I'm going to try to apply them to the cells. I've got this set of 4 again. I'm looking at the multiplicative matrix between the two of those. Well, 4 times 4 is 16. But out of those 16, basically everything cancels out except symmetry and discontinuity and asymmetry and continuity. Those are literally the only 2 valid methods. Everything else adds out. That's the proof part. And at this point, the latch in the door of the garden gate has just clicked closed behind you, and it's over. You've gone past the point where turning around and going back out the gate is no longer possible. Because we've just said something about the nature of symmetry, asymmetry, continuity, and discontinuity that is equally as deep as the notion of comparison, the notion of the very foundation of epistemic process, of symmetry and continuity, and where they can be used and under what circumstances themselves. What is symmetry and discontinuity ultimately about? The third person perspective, the mode of the omniscient. What is asymmetry and continuity ultimately about? Well, fundamentally, it's the mode of the first person. We experience consciousness, the subjective, in the sense of being continuous, in the sense of I have a notion of myself as an integral being, and asymmetric in the sense that I always distinguish between the past and the future in every first-person perspective. I simply am experiencing the now as distinct from the then. I'm experiencing the here as distinct from the there. And I'm distinguishing this moment of what has actually happened from that moment of what could have happened instead, so-called counterfactual. And these notions of here-ness, nowness, and the notion of the real as being this happened, right? If you go to quantum mechanics, you have the many worlds of interpretation, but it isn't many worlds. We're in this world, and the meaning of this world is specific, the same way that the notion of here is specific, and the notion of now is specific, but there's no way to hold the notion of any one of those three specificnesses in the notion of a third-person perspective. In physics, there is no time distinct from space. There is no notion of a particular moment that is the now, or a particular place that is here that is different than there. They're all the same. That's the idea of symmetry, in a sense, being realized within the third-person perspective. And of course it's the case, because we're talking about the object. Right? Notice what we're actually doing here. We're speaking about the lowest possible notion of knowledge that is possible to have, both in the sense of what does it mean to be objective? What does it mean to be subjective? What does it mean to be in a third person? What does it mean to be in a first person? And Ben, you asked about, the third pole. Well, that would be the transcendent. It's not on a map. It's altogether elsewhere. Right? In effect, the transcendent is infusing the immanent, but it's invisible to the omniscient. Right? The relationship of peerage, the relationship of communication. This is a thing which is immanent in a different way than the idea of my firsthand experience. It's about the relationship itself. And in that particular sense, there's a quality of that which is not describable from either a first person or a third person perspective. The second person is an actual beingness, but it's not the kind of beingness that is essentially holdable from either a first person or a third person perspective exclusively. It is essentially altogether other than. It's its own ontological class, and it has no name. So in this sense, there's a reality to it, because, in effect, if I were to give it a name, I would have moved it into the omniscient. And if I were to speak the name, I would be pretending that I had moved it into the immanent. But that's no longer the transcendent. So the transcendent is, but it can't be either described or experienced as itself. It can only be described and experienced in the projection. And this is a very deep truth. This is one of those things that to some extent we just have to account for. But the idea here is that when we're basically talking about the incommensuration theorem, we're basically talking about now, in this sense, the boundary between the known, the unknown, and the unknowable. The unknowable is the transcendent. The known is the immanent. That which is unknown is effectively the omniscient in this case, because there's parts of it that have become the known or describing of the known, and there are parts of it that are not yet known. All the proofs of mathematics that we do not yet know, all of the theories of physics we have not yet discovered. So in principle, we could discover them. Might take a long time, might take a real age of very powerful supercomputers or minds, maybe smarter even than any that live currently. But there's a notion here that there is a kind of knowledge which is neither expressible just in the first person perspective or expressible in the third person perspective. And the incommensuration theorem, metaphysics itself, is that kind of knowledge. You'll notice I didn't do the proof of the incommensuration theorem just in the first person. I started there, but then I was making observations, things about descriptive and proscriptive. I made observations about correspondence, whether or not the concept of symmetry actually corresponded to the way it was actually used in the real world. The reason that the notion of comparison was important as the foundation of perception, or as the foundation of measurement, or as the idea that the scientific method itself is corresponding to these sorts of dynamics of the relationship between the first person as experiment and the third person as, in a sense, represented knowledge, something written in a textbook. So in this sense, where does the incommensuration theorem live? Well, it lives in this sort of mysterious space that is altogether other than both a purely analytic description, because if it was purely analytic, it would just be math. It wouldn't have correspondence. The semantic relationships wouldn't bind. But this is a proof that depends upon the semantic relationships being what they are. Because without those semantic relationships, the proof doesn't apply to anything. But because of those semantic relationships being written into the very nature of epistemology and cannot not be written into the nature of epistemology, then the proof applies to epistemology. The results of the proof apply to epistemology. It is inherent in the nature of the relationship between the subjective and the objective that we cannot have that relationship be both perfectly symmetric and perfectly continuous at the same time. Point blank, period, no exceptions. And why do I get to know that? Because of the rigor of the proof itself. And so you say, okay, well, you just made a really badass claim. Like, I walked with you, we did these steps, but that level of knowledge, that what the fuck? And then you begin to see that actually this isn't the first time. This is the third time that humanity, maybe even the fourth time that humanity has encountered this. In fact, as you start to dig into it more, you discover, oh, wait, actually, maybe the fifth time. What are the examples of this showing up already happening? Well, one of the examples is way back in, I don't know, early 1900s, this guy by the name of Godel. I'm hoping I'm pronouncing his name properly. I keep wanting to say Godel, but that was because, I read it when I was by myself and had no tutors. So in effect, there was a mathematician that was essentially responding to this thing called I'm going to call it the Vienna Circle or the Whitehead Project, or this idea that mathematics could be unified, that we could essentially develop a body of math that was completely coherent with respect to set theory or logic or some set of axioms that would allow us to derive all knowable truth. That there could be a base of anything that is truth in math, right? Proof that is that one way or another, we're going to be able to connect these ideas, postulates or premises or axioms or however wanted you to set up as, we're going to take this constellation of concepts and we're going to be able to use these tools to manipulate them. And from that, we're going to know the entire tree of all things that can be known. And that was a sincere effort. It's like some people basically spent almost their entire lives trying to figure this out. And then this guy came along and he basically said, hey, if you define each statement in a proof in this sort of way, and I'm going to correspond a number, and then these numbers can themselves be related in terms of proofs. And all of a sudden, if we do this sort of meta argument about how the proofs describe themselves using this number system, we can create a contradiction. And the mathematics associated with that's pretty elaborate. I mean, it takes a fair amount of study to work through all the details. But the upshot is that you have a system attempting to describe itself. And when it does, it pops out this thing that basically says, well, this contradiction occurs, and the contradiction is written in such a way that you can't really have a hope that it would be both complete and consistent, i.e. mathematics be both complete in a sense that it describes all knowable things that are true, and consistent in a sense that it doesn't get anything that says something is both true and false at the same time. So in a sense, okay, when that person made that observation, it torpedoed the entire project, because it so happens that Godel basically was careful in the way he represented that proof. And people studied it and they looked at it and they basically said, you know what, I can't find a flaw in this. This is airtight. It's a rigorous proof. We have to reconceive of how we think about mathematics. Now, at this point, a reasonable person might be saying, wow, why are you connecting the notion of this mathematician's proof and this thing called the incommensuration theorem? Well, again, it turns out to hinge on the definitions. What does it mean to say that something is consistent, i.e., that it can't be both true and false at the same time? Well, in effect, I'm basically trying to assert a notion of symmetry, that the truth that's held in the premises and the truth that's held in the transformations are going to allow us to know the truth of the outcome. So I shouldn't have, one derivation path starting with the same premises and going one direction and arriving at, point A. And then I start with those same premises and I use another derivation path, which goes through, another course and also arrives at point A. But one of them tells me the point A is true and the other tells me the point A is false. Right? That would be a violation of symmetry. It's the same context, but the content is different. One says it's true, the other says it's false. If the notion of truthfulness is a content, and the position A in the hyperspace of all possible proofs or all possible statements is essentially the context, then in effect I've violated symmetry. So the notion of consistency in mathematics cannot not be exactly equivalent to the notion of symmetry. And so what about this notion of completeness? Well, the notion of completeness would basically be like, think of the proofs as being like, again, paths through the hyperspace of all possible statements. And in effect, what we're basically saying is that starting in any position in that hyperspace, I can get to any other position in that hyperspace by following the paths of truth. And that there are no islands, i.e., there are no unreachable places, things that are true, but I can't get there from here. If all I can do is walk and I don't have a boat, an island is a place I can't get to. I'd have to use another tool like swimming or a boat or an aircraft or something. But if those tools aren't part of the picture, then the island is inaccessible. And if the tools that I'm using are methods of proof, and those tools can't get me to certain truths, then in a sense, I now have a system which is incomplete. It can't get to, can't describe, can't derive the truths that are on those islands, the statements that are true, but aren't true for a reason that we can essentially derive from the premises that we have, using the tools that we know. That's incompleteness. And you'll notice that when I'm talking about paths of how to get there from here to there, that's a notion of continuity. Because any place that there's no path from here to there is essentially the very essence of what it means to be discontinuous. The land had a discontinuity in the water. You have essentially a place where the land stopped, the water began, and then the water stopped, and then there was land again, the island. The land was discontinuous, at least as experienced from the surface. Now, we all know that the metaphor doesn't allow for going underwater and stuff like that. But again, that would be methods beyond those available to us at the time. So is it the case that we can have a notion of continuity, connects everything, no islands, and a notion of symmetry, there are no contradictions, that every path leads to a place, and if there are multiple paths leading to that same place, that you're arriving at the same place, and the thing that you get there when you're there is the same. In other words, that arrival at a place is path independent. So in effect, it cannot not be the case. Now notice I'm using the strict form. Cannot not be the case that there's a one-to-one correspondence between the notion of completeness and the notion of continuity, and the notion of correctness, or in this particular case, non-contradiction, and the notion of symmetry. Complete and consistent. So in effect, I've now just established that the net result the essence of the net result of Gödel's incompleteness theorem is in an exact one-to-one statement, making exactly the same statements as the incommensuration theorem. The ICT is a generalization of the Gödel proof because it's using a more powerful language and was a simpler derivation and covers more than just math. It's basically saying the same thing to change the course of the history of math. And you don't have to take my word on this. You can look it up. And so in this sense, we now have an observation of a version of the ICT showing up 100 years ago. And the same thing happened in, what was it, 64 or 67? There was this thing called the Bell theorem. And in physics, we basically were trying to come up with the laws of the universe, i.e., what's knowable as do the same laws apply everywhere, right? That's a kind of symmetry notion. But the thing is that people at one point were basically saying, well, can I conceive of physics purely in the notion of causation? Can I think about it in a sense of local influences? Remember, I mentioned way back in the beginning this thing called the Minkowski diagram, that influences can only travel at the speed of light or less. The causation can only move through the universe at the speed of light or less. And so in effect, if I want to have, something that provides predictability or utility in the sense of being useful in a technological sense, then being able to structure it purely in terms of causation is essential. But all of a sudden, we were having these phenomena in quantum mechanics of this sort of entanglement. So there's this real question: can we rework the notion of quantum mechanics that doesn't have this spooky action at a distance, right? If you look that up, you'll see there was a huge amount of conversation around that concept. And again, I'm talking about it not in a popular sense. I'm talking about it in the essential sense. What was that debate actually about? It was actually about, can we transition from this apparently flawed model that incorporated this entanglement thing to a classical model, i.e. hidden variables, descriptions, and so on and so forth, that could account for the observed phenomena in a purely causal way. And those are called hidden variable theories. And so there was this observation. If we basically are looking for entanglement, and we're trying to test if there's a way to account for that entanglement in a way that is not in any way dependent upon these non-causal influences, then this inequality should show up a certain way in actual measurements. And it turned out that didn't work. That in effect, there was this irreconcilable entanglement that could not be explained purely in any causal way. And there were lots of arguments about this. And it wasn't until something like 5 years ago that all of the loopholes were closed, that basically a version of the experiment was done that rejected the notion of things like superdeterminism, like maybe the entire structure of the universe is fixed, and there's therefore a correspondence between, the randomness of choosing to measure this entanglement in this way and this other one. It was like a lot of ridiculous ideas. But the thing is that there was this deep, desperate desire to both maintain the notion of causation, i.e. the principle of locality, and the notion of lawfulness, i.e. that physics could actually describe what was happening in the universe pretty much everywhere. Right? They didn't want to have a theory of physics that had exceptions that, hey, it works in this galaxy, but doesn't work in that one, or it works on this planet, but it doesn't work on that one. Like, that's no good. Or that the laws are expressed in something other than purely causal dynamics, because if it was, then effectively the law is useless. So they wanted a set of laws that were both universal and expressed in the language of pure causation. But now comes along this Bell theorem and says, take your pick. You can get one or the other, but no theory of reality, no matter how conceived, can be both purely causal and purely applicable to everywhere. Either you give up the idea of lawfulness, you give up the notion of symmetry, or you give up the notion of causation, or i.e. the notion of locality. Take your pick. This was a choice that physicists had to make. The community was forced into a deliberation as to which of these things is more important. Well, because physicists inevitably are, in a sense, arguing from the third person point of view, they picked symmetry over continuity. They gave up the notion of continuity. They gave up the notion of causation as being the one and only way to describe models of lawfulness. They said maybe there's exceptions. Actually, no, there's definitely exceptions. We can't understand the exceptions in terms of causation. We have to accept that. But aside from that little niggling thing, we're going to talk about the laws of the universe in a causal way, and we're just going to basically just handle that as exceptions. And maybe we can leverage this into some sort of technological thing. Welcome cryptology and quantum computing and a few things like that. But the notion here is that the Bell theorem is essentially asserting, based upon actual experimental results, and again, unambiguous, uncontroversial logic, although, believe me, a lot of people wanted it to be controversial and tried to make it controversial. This was a debate that covered decades. Careers were made on this argument. And in effect, it's essentially saying that no theory of reality can be perfectly lawful and perfectly local. Well, what does lawful mean? Well, I already just mentioned that it's connected to the notion of symmetry in the fundamental sense. Same laws apply everywhere in the universe. The laws of the content, anywhere in the universe at any time and position of possibility or probability, that there's a consistency of these regular patterns being observed. And so if we're going to say that there's anything that's knowable about physics, we're going to keep the notion of symmetry. And then, well, what about this notion of locality? Well, as I just mentioned, it's connected to the notion of measurement itself. It's connected to the notion of continuity in the sense that locality and continuity are the same. Go back to that notion of a discontinuous function I mentioned earlier. Right? I shouldn't have a situation where moving an infinitesimal distance in space results in an arbitrary discontinuity in the strength of the interaction or the field. Right? I can't have edges in the perfected sense in the physical universe. There's always going to be some sort of connectedness that's happening. There's no such thing as perfect disconnectedness. So in this sense, we're looking at a connection that is, again, indelible between the notion of continuity and the notion of locality. So in effect, the Bell theorem is essentially saying that no theory of the universe, no embodiment of physics knowledge can ever be correct if it asserts both perfected symmetry and perfected continuity. The Bell theorem is in direct one-to-one correspondence with the incommensuration theorem. That's observation number 2. Without going into the details, observation number 3, the mere fact that there is a theory of general relativity and a theory of quantum mechanics that, oh, by the way, has never been reconciled, right? There has been an effort by the best and the brightest minds the world has ever produced in the last 100 years. Not to say that people earlier ages were any less smart, but just that the people that even knew that this was a question, the very best and the brightest, have attempted to come up with a theory of physics that both held the truths of general relativity and at the same time held the truths of quantum mechanics and reconciled these two into some grand unified theory. You had the epiphenomenal and the sort of epicycle theory of strings, which after, 30 or 40 years, people have more or less given up on, except for a handful of true believers. But they've never come up with anything testable. And then you have, a lot of these people that are trying to do quantized gravity, and you've got all of this stuff that's going on in CERN, which is, every imaginable theory. There's been something like 10,000 papers published on this topic of trying to reconcile quantum mechanics and general relativity. And after, something like 50 years of the best and the brightest working on this problem, no one has been able to sort out even how to begin to solve this particular thing. Why? because it turns out that one of them is describing time in a quantized, discontinuous way, and the other is trying to describe time in a continuous way. One of them is essentially trying to look at certain kinds of asymmetries. The other one's trying to look at certain kinds of symmetries. In every place that we see the conjunctions of symmetry, continuity, asymmetry, and discontinuity, that the conjunctions are just wrong. I'm not going to go into the details, but if you look into it, you basically notice that there's a reason why these two theories of physics, which have been thoroughly tested at the scale of the small and at the scale of the large, and yet in the middle, the only thing we can use is Newton, because at the scale of the small and at the scale of the large, they give us different answers. Why? Well, partially it's a reflection of this thing called the Incommensuration Theorem. It turns out it gives us a way to know that there is no such singular mathematical formulation that will bind these two foundational substrate theories. The math is inconsistent in the same sort of way that the Godel theorem was pointing out earlier. And again, this is a instance, it's an observation of incommensuration theorem. Now that, by the way, is one of those things that once you see it, you can't unsee it. And in effect, what it does is it changes the course of literally all of the research that's being done. It basically changes the very meaning of what it is to do particle physics. We no longer can look for it as a physical or mathematical description. We can only reconcile it at a metaphysical level. So when the philosophers were essentially kicked out of the discussion some 50 to 100 years ago, right, back in the 70s, progress in physics stopped. And I'm not the first to have made this observation. It stopped. It's been dead in the water for 50 years. And so in a sense, we've now just basically said something that is at least as profoundly important as anything that has been said in either the Godel theorem or the Bell theorem. We've again basically said, hey, the notion of what it means to know reality is constrained in this specific way. We can know the nature of the constraint. That does not give us an ability to arbitrarily transcend it using the tools of math. And this is a hard thing for people to hear. Almost everybody rejects this. It's essentially something that goes against the grain of what people wanted to do back in, the early days of like I said, the 19th century, or 1900s rather, that there was this deep impetus. People really wanted to come up with a grand unified theory of mathematics. If you could do that, you would have had your name in the history books for the rest of time, right? You would be infinitely famous forever, at least as far as Western culture would ever keep track of such a thing. And then, if you were able to come up with the theory of physics, which unified quantum mechanics and general relativity, a quantized gravitation, or a string theory that worked, or any other bizarro idea that someone had managed to come together, again, you would have had the highest level of prestige that is possible to have, because you would literally have outdone Einstein. You would have outdone Newton. You would have outdone literally every other physicist, the best and brightest that has ever worked on these problems in the entire world. Wow, that is a thing to put on your resume or whatever in your CV, right? So here is this weirdo, myself, coming from way out beyond the beyonder, like beyond the edge of the being itself, and essentially saying, oh, by the way, there's this thing called the Incommensuration Theorem, and it's just letting you know that that's just not going to happen. Obviously, this is not going to make me very popular, and at this particular point, I imagine that most people are steadfastly avoiding this particular body of knowledge. This is why there's never been a presentation in the physics community, certainly never been a presentation in the mathematics community. I'm just basically sitting around waiting for someone to notice that this has happened.
Where else can the ICT be applied?
The Poincaré sphere, or thinking about the Heisenberg uncertainty principle, i.e. that I can't perfectly know position and momentum at the same time. It shows up in things like the Fourier transform, that I can't perfectly localize the a spike in the time domain and a spike in the frequency domain at the same time. It's inherently not the case. Fuzziness in one can be precision in the other, and vice versa, or I can have fuzziness and fuzziness, but I can't have precision and precision at the same time. And by the way, perfect fuzziness isn't possible in both cases either. So in this sense, there's an underlying recognition that the incommensuration theorem is actually pointing to something about the nature of the real, about the nature of choice, change, and causation, about the direct meanings of these terms, about the meaning of what it means to be objective and subjective. Notice that we have actually made some very specific claims. We said, wait a minute, it is the case that the objective is understood in terms of symmetry and discontinuity. It must seem to be the case that particle physics is a good way to describe the universe. Right? Particles is a perfected discontinuity. And symmetry basically is talking about that every electron is just like every other electron. In fact, it could be one electron zinging back and forth in time, and we wouldn't be able to tell the difference if there was one or many. Or just the idea that every particle is indistinguishable is a symmetry concept. And so in effect, there's a notion here that we have just characterized the third person, the omniscient, the objective, as being described by symmetry and discontinuity and causation. And similarly, we've just described that it cannot not be the case that the first person, or in this sense, the subjective, is described by continuity and asymmetry. And that this is built in just as deeply into the nature of the subjective as symmetry is built into the objective.
How does the incommensuration theorem, ICT, and the metaphysics show up in everyday life?
How does it show up in everyday life? Well, how does choice, change, and causation show up in everyday life? I mean, these things are so intrinsic to the very nature of perception and of being and reality itself that to some extent it's showing up in every millisecond of every moment of every day. But I can give you some ideas. I can basically say, to the extent that it seems that the first person perspective and the third person perspective are in some way irreconcilable, i.e., the hard problem of consciousness, or, oh, by the way, yet that is yet another manifestation, right? Real easy to go from the first person to the third person. But again, there's a symmetry breaking. How the heck do you get from the third person back to the first person? Theory is not enough to explain firsthand experience. Where does the symmetry breaking that is the thing that makes this universe unique to itself, where does that happen? And of course, you can apply the anthropological argument all you want, but it's not satisfying. Where does it actually land? That the specificness happens. Well, somehow we got to get back from the third person to the first person, but it's certainly not going to happen through any direct course, because guess what? Axiom 2. The only way to get from the third person back to the first person is via the second person. Isn't that interesting? We don't make sense of things by ourselves. So how does this show up in a first person sense? Well, Habermas pointed to this. Reason emerges in the conversation. It emerges in the dynamic of communication. Communication is the superpower that moves us from just a social species, or from just individuals into social species, but the fact of the nature of our communication moves us beyond the ants or the bees. Communication's able to be recursively constructed. There's been some real research into this that talks about the nature of language as recursively enumerable. And some of the deepest thinkers in the world that are thinking about language design have come to notice this. So in a sense, what is a way in which we experience axiom 2 in the first person sense? Well, we figure shit out by collaborating with one another. That's the second person transcendence beyond the third person identity to arrive at a first person choice, either as an individual or as a community. And so in that sense, to the degree that we are experiencing change in causation and expressing in choices, we are embodying both the axioms and the incommensuration theorem, and cannot not do that. The very fact that we experience identity in the sense of a continuity of consciousness. Who are you if you can't remember anything? Let's go back to Descartes for a moment. I think, therefore I am. In one series of essays, I pointed out that, well, actually, that's really interesting. It's basically asserting that a process, thinking, results in an identity. I am a being. Process as being. That's what I think, therefore I am, is actually asserting. That all being is based upon process. And he did it using this methodology of anything that I can doubt, we're cast it out. We're going to leave it as just, if there's any way, even in potential, that I could doubt it, then I'm going to assume that it's not true. I'm just going to do the things that I can't doubt. And it turns out that doubt as a process has some intrinsics. Are you going to be able to have a concept of doubt without a notion of truth or false? Probably not. So it turns out that anything that's intrinsic to the nature of doubt can't be doubted, because if I try to doubt it, I'm instantiating the intrinsics of doubt, and therefore the intrinsics of doubt cannot be doubted because they're carried along with the process itself. Any action to attempt to get away from them creates them. So you can't get away. So therefore, Descartes somehow managed to, I think, overlook this, but the idea is that the intrinsics of doubt are therefore also knowable as truths. But it turns out that's not all, right? There's a couple of other things that were missed. For example, I think, therefore I am. Well, what if you can't remember anything? You do the thinking, but you forget that you're thinking before you notice the I amness. So now all of a sudden the notion of continuity is built in. There has to be a connection between thinking and being. The becomingness is therefore also part of the picture. Becomingness as that which is not yet to that which is. You asked about creation earlier. Here's an example. I think, therefore I am is a moment of creation. It creates the very sense of I have identity, I have memory, I am. I know who I am. I know I am a thinking thing. And so in this sense, there are some intrinsics with it. What else is the case? Well, the notion of thinking is a process, it's a choice, it's a kind of expression. Say I couldn't think, I didn't have the choice to think. Without the expressive part of it, thinking as a action, I don't have the perceptive part of it, noticing of being. So in a sense, the expressive part and the perceptive part co-occur. Interaction can't be conceived of without both perception and expression as subclasses of the general concept of interaction. And you'll notice this is in the book also, right? So in effect, what you're observing here is that even in the most rudimentary sense of the most basic perception or the most basic expression, that there cannot not be this relationship between doing, being, and becoming. And that all of them tie in together. They're distinct, inseparable, non-interchangeable. The axioms are reemerging again. Can I know everything there is to know about doing, being, and becoming? Well, no, I don't know everything there is to know about creation. To some extent, creation is neither observable nor repeatable. There is an inherent unknowingness to creation, a newness that is ever present, an unpredictableness. So in that sense, the Descartes observation is an experience of not only the axioms and the modalities, but the incommensuration theorem itself. It is a reification of the relationship between the objective and the subject. I don't know that this helps. Like I said, we're talking at such a level of fundamentalness that to even use the concepts of perception and expression is tricky, because we tend to think of them from our own lived experience of these things, but we're talking about them at such a rudimentary level that it's not just your experience, it's the experience of any alien in any universe. Any notion of consciousness itself is going to be an embodiment of these truths. So our notion of perception and expression is way the heck too anthropomorphic for the needs of this actuality.